Okay, welcome. So today we're going to talk about improper integrals. Okay, so improper integrals are basically integrals of the form some a to b f of x dx, where the interval ab may include some discontinuity, okay. B, A or B might be infinity or negative infinity. Or both. And that's pretty much covers it. So let's take a look at just the sort of canonical ones. Okay, so let's take a look at the integral from 1 to infinity of 1 over x dx. And we're going to ask, what does this have any meaning? Okay, now for this one, actually, there is no meaning. So we'll see what happens. So what we're going to really do is we're going to say, we're going to define this as a limit. This is going to be the limit as t goes to infinity, okay, the integral from 1 to t of 1 over x dx. Okay, so now we know the antiderivative of 1 over x, that's natural log. That is natural log of x from 1 to t. So this is limit as t goes to infinity, natural log of t minus natural log of 1. Natural log of 1 is 0, but this goes to infinity. So this one we say does not have meaning. This limit does not exist. Okay? But we can do more generally, or yeah, let's take it the general case. Okay, let's take R. Actually, we usually use P. Let's take P not equal to 1. Okay, so we're going to take the limit as t goes to infinity from 1 to t, 1 over x to the p dx. So this is usually, you could write it as shorthand, the integral from 1 to infinity of 1 over x to the p dx. Okay, so now the antiderivative here, I got to be careful, otherwise I'll screw it up. It's x to the negative p, so you're going to add 1. So this is going to be the limit t goes to infinity, x to the negative p plus 1 over negative p plus 1. I'm going to write it as 1 minus p. Now, we're staying away from p equals 1, so we don't have to worry about this being 0. Okay, so that's another reason to sort of split this up. Okay, let's take a look at what's going on with this limit. Okay, so as t goes to infinity is going to be 1 over 1 minus p, and then it's going to be t to the 1 minus p minus 1 to the 1 minus p, which is just 1. Now, what happens as t goes to infinity? Well, let me rewrite this just a little bit to make it a little clearer. T goes to infinity, again, 1 over 1 minus p, t over t to the p minus 1. Okay, so what happens? So if p is bigger than 1, okay, if p is bigger than 1, this thing is going to be bigger than this thing, right? And so this is actually going to converge. So this becomes 1 over 1 minus p negative. So 1 over p minus 1. Okay. If p is less than 1, then this actually is smaller than t, right? So then if that happens, this diverges again. Okay, so if p is bigger than 1, it converges. If p is less than 1, it diverges. Okay? All right, I'm going to have to come back with another video. See you on the next one.